Hello everyone, and welcome to another video for Liberal Arts and Algebra CR and Algebra 2. This video is going to cover a few topics today. We're going to talk about adding functions, subtracting functions, multiplying functions, and then finally inverse functions. This will be the one video you'll have for 2 weeks, and it'll be the last 2 weeks of this school term. Unless you're missing any assignments and have to make those up. So let's get right into it. Hopefully this video is not going to take very long. These are pretty easy concepts. So let's get started with adding functions. Alright, so adding functions is literally what it says. We're going to add two functions together. This can be symbolized in a few different ways. It can be symbolized as f of x plus a g of x. And of course we could have plus an h of x. We could add multiple functions. We could keep going, z of x. Now for your homework though, mostly this is what you're going to be looking at. But it can also be symbolized f plus g and then x on the outside. So these are two ways that you might see it. Now this does not always have to be x. This could also be, let's say, f plus g of -2. That means that I need to add f and g together and then evaluate at the number -2, or evaluate f at -2, evaluate g at -2, and then just add them together. There's a couple ways of reading it. Subtraction works pretty much the same way. So subtraction, you could have f of x minus g of x, or you could have f minus g of x, and yet again we could still say it's f minus g, let's say -3 this time. Okay, so any of these could work, and then we're going to talk about multiply, but we'll do that later. So for right now, let's jump to our first problem. I want to know f plus g of x, and I want to say that f of x is 4x plus 4, and g of x is 3x squared minus 1. Okay, so I want to add these two functions together, so I'm going to set it up as 4x plus 4 plus 3x squared minus 1. And I'm going to combine like terms. Well, there's no other x squareds, so I've got 3x squared. There's no other x's, so I'm just going to have 4x. And then I have 4 and -1. These are both numbers, so I'll combine them together. 4 subtract 1 is positive 3. And this would be your answer, f plus g of x. As I said in the beginning of the video, these are not hard. They are more than likely just combining like terms. What about f minus g of x? And we'll say that f of x is x, and g of x is -2x squared plus 9x. So two functions. This time I'm going to subtract. Now this order matters. You can't do this, subtract this. It has to be in the proper order written above. So f first, then subtract g. So x, subtract, and then g. So I've indicated f and g above the functions. Now we're going to perform subtraction. What I would do right here, so can't hardly see that, right here, I would go ahead and distribute this negative. So -1 times -2, that's positive 2. -1 times positive 9 is -9. Now combine like terms. Well, there's no other x squareds. And now I have x and negative 9x, which we know is negative 8x. So 2x squared minus 8x. Alright, let's try another one. This time let's actually, instead of saying f and x, let's talk about a number. F minus g of 10. So we're going to do function f, subtract function g, and then evaluate it at 10. And I want to show you two ways this can be done. We've got, and let's go ahead and label out what f of x and g of x is, 2x plus 3, and g of x is x. Now, two ways this can be done. One, you can do what we've been doing and subtract them out, and then evaluate at 10. The other way is you can go ahead and evaluate and then do the subtraction. So I'm going to show you both so you can pick which one you prefer. So over here, move this thing out of the way, we've got 2x plus 3, subtract g, so subtract x. Combining like terms, I get x, 2x minus x is x, and I get the number 3. Then I evaluate at the number 10, which means I plug in 10 for x. Well, 10 plus 3 is 13. But I could also do f of 10 minus g of 10. So f of 10, that's 2 times 10 plus 3. Well, the 2 times 10 is 20 plus 3 more is 23. G of 10, well, that's just 10. It's 10. 23 subtract 10. So we did f subtract g. Well, that's also equal to the number 13. So two different ways of performing the problem, both giving the same answer. I do not mind whatever technique you use, but you need to use one of the two. Either go ahead and add them together, combine like terms, and then evaluate, or evaluate and subtract, or add, depending on what situation you have. Okay. So over here, let's do two more of these, and then we're going to switch over to multiplying. And I'm going to go ahead and write these out and let you work them. We'll move this thing out the way. F minus g, 5, and then the other one is going to be p plus q of negative 3. So f of x is going to be equal to 5x plus 5. G of x is going to be negative 5x plus 4. Over here, p of x, negative 3x plus 4. And q of x, x squared plus 2x. Alright, so I want you to go ahead and pause the video at this point, work these two out real quick, and then come back. Alright, hopefully you've paused the video and come back to see the answer. For those of you that are just wanting the answer so you can move on to something else, this over here is 51. This one over here is going to be 16. And for those of you that need to see the solution, I'm going to work those out now. 5x plus 5 minus negative 5x plus 4. Distribute my negative. So I got 5x plus 5 plus 5x minus 4. Negative, negative cancel. Negative, positive becomes negative. Combine like terms, 10x and 5 minus 4 is plus 1. X has to be the number 5. So 10 times 5 plus 1, that's 51. Over here, p plus q, so I've got negative 3x plus 4 plus x squared plus 2x. We only have one x squared, no other x squared term. Negative 3x plus 2x is negative x. And 4, we don't have any other numbers, so it's just plus 4. Evaluate with the number negative 3. So negative 3 squared minus negative 3 plus 4. Negative 3 squared with parentheses, that's positive 9. Because negative 3 times negative 3 is positive 9. A negative negative here cancels out, leaving me a plus 3. And then I've got a plus 4. 9 plus 3 is 12, plus 4 more is 16. Alright, that's all there is to adding and subtracting. So now we're going to move on. We spent about 10 minutes on that. Now we're going to move on to multiplying. So the multiply. Now we are not going to cover division in this video. Division would have to have its own separate video. And in fact, I excluded division off your assignments for that exact reason, because those videos are going to be long. Because we would have to re-go over long division and synthetic division. So we're going to just talk about multiplication here. We represent this two ways as always. F of x. Well, actually 3 ways. You can write it like this. F of x, g of x. That means multiply. You could say f of x times g of x, like this. That also means multiply. Or, third way, inside parentheses, f times g of x. So all 3 of these mean multiply. And remember, we can always say that with any of these, that we, instead of x, we have a number. So I could say this is f times g with the number 2, if I really wanted to. Okay, so 3 ways to do it. Mostly, we're going to be focusing on this representation, because that's the most commonly used on your assignment, but any of these are valid forms. All right, let's get started right away. All right, so we've got f times g of x, where f of x is 3x, and g of x is negative 2x squared plus 8x. And all they want you to do is multiply them together. We're not evaluating. There's no number here. This is going to be set up similar to the distributive property, especially when this term is just linear. We've got a 3x, and we're multiplying it by a negative 2x squared plus 8x. Well, this looks like distribute. I'm going to multiply this times the first term, and then this times the second term, and that's going to give me my answer. So 3x multiplied by negative 2x squared, we're going to do it in steps. 3 times negative 2, it's negative 6. X times x squared, how many x's do I got? 2 here, 1 here. That means I've got 3 of them. Same thing going over here. 3 times 8, well, that's 24. X times x, how many do I got? 1, 2. And there's my answer. Okay, going to the next one. I'm just going to go ahead and do it on the same page. Draw a line to separate. Got f times g of x, where f of x is 5x plus 5, and g of x is 2x. Multiplying them together. 5x plus 5 times 2x. Well, this looks like distributive property again. It's just the terms in the back. Remember, multiplication is commutative, which means that no matter how I rearrange these, a times b is still b times a. That means this is the same as 2x times 5x plus 5. If that just makes it a little bit easier for you to, work out the problem, writing the 2x in the front instead of in the back. Works out the same. Distribute. 2 times 5 is 10. X times x, how many we got? 2 of them. 2 times 5, yet again, is 10. X, and there's none there, so I still have just 1. Okay. So see, these are not difficult either. Very simple problems, very easy to work out. The hardest they get is when we have to introduce the FOIL or double distributive, but you guys know how to do that, so that's not a big deal. F times G of X, in fact, we're going to do one of those right now. We got F of X is X plus 6. G of X is negative 4X plus 3. So, multiply them together, X plus 6, negative 4X plus 3. Now, we've got to do distributive property, but do it twice, or do the FOIL method for those of you that know how to do FOIL. I'm going to do double distributive. X multiplies to both. So X times negative 4X. That's negative 4X squared. X times 3. 3X. The 6, it multiplies to both. 6 times negative 4X. Well, I'm just going to multiply the numbers. That's negative 24X. 6 times 3, that's 18. Add them going down. I lined them up so that way they are already in the combined like terms set up. There's nothing here, so I just got the number on top, negative 4X squared. Got two numbers here, so I got to combine them together. 3 and negative 24 is negative 21. And 18 doesn't have anybody to hang out with, so we just drop him down. Or her down, depending. Okay, negative 4X squared minus 21X plus 18. I have multiplied the two functions together. Okay. Let's take it a step further. What if I wanted F times G of 2? Yet again, two ways to do this. You've got the F times G and then multiply them, get them, plug them in with 2, or we've got the F evaluated at 2 times the G evaluated at 2. Okay, so you can still do that split technique that we did before. And I'm going to show them both, just so we got it. Alright, and for this case, F is going to be 3x plus 1, and G is going to be negative 3x squared. And I'm going to go ahead and write it in the format that we generally like, with the single term in front, and then the other term. Doesn't matter. Commutative, they work both ways. I'm going to distribute negative 3x squared times 3x. Well, negative 3 times 3, negative 9. X squared times x, I've got 2 here, 1 there, so that makes 3 of them total. Negative 3x squared times 1, well, that's anything times 1 is just what we multiplied by. Evaluated the number 2. So it means I got everywhere I see an x, I put in the number 2. So right here, 2 to the third power, 2 times 2 times 2. That's 8. 2 times 2 here, 2 squared, 2 times 2, that's 4. Well, negative 9 times 8 is negative 72. Negative 3 times 4 is negative 12. Total, I've got negative 84. Well, let's check it over here and make sure that worked out. F of 2. Well, that's 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. And G of 2, plug in 2, negative 3, 2 squared is 4 times the negative 3 is negative 12. Well, now it says that F times G, so 7 times negative 12, that is in fact negative 84. So 2 different ways, same answer. And you can use either one. All right, a couple more. Let me make sure we got 1, 2. Yep, 2 more of these. And then we are going to switch over to inverse relations and inverse functions. Okay, so first one we're going to do, in fact, I'm going to go ahead and write them down, let you work them out, just as before. That way you get to your little bit of practice. First one's going to be f times g with the number 3. And your f function is going to be 3x plus 5. G function, 5x plus 5. Okay. And then on the other one, we're going to do p times q again with -2. So p function is 4x plus 2. Q function, x squared minus 2x. Okay, so go ahead and work these out real quick, and once you get done, come back and check your answer. Okay, hopefully you've gone and checked your answer and worked these out so you can check your answer. For those of you yet again that want to go ahead and move on, over here we're going to get 280. And on the other one over here, we're going to get -48. So if that's the 2 answers you got, you can go ahead and fast forward the video to the next topic, unless you just want to see them worked out. Over here, we're going to multiply together 3x plus 5 and 5x plus 5. Going to do double distribute. 3x and 5x, that's going to be 15x squared. 3x times 5 is 15x. And then down here, 5 distribute, 5 times 5 is 25x. 5 times 5 on that one is also 25. Combine like terms, we have 15x squared plus 40x plus 25. Evaluate at the number 3. So 15 times 3 squared plus 40 times 3 plus 25. 3 squared is 9. Fifteen times 9, that's 135. 40 times 3 is 120. And then 25, that adds up to be 280. Okay, over here, we're going to do our multiplication yet again. 4x plus 2 and x squared minus 2x. Distribute first. So I have 4x cubed, and 4x times -2x is -8x squared. Distribute by 2. 2 times 2 times x squared, that's positive 2x squared. 2 times 2x is -4x. Now we're going to combine our terms going down. We get a 4x cubed. Here I get a -6x squared, and here I get a -4x. Evaluate at -2. And we'll work up here because these are a little bit longer. 4 times -2 cubed minus 6 times -2 squared minus 4 times -2. Well, -2 cubed is -2 times -2 times -2. That gives me -8. Here, -2 squared, -2 times -2, that's positive 4. And here we just have -4 and -2. Multiply and add. 4 times -8, -32. -6 times 4 is -24. And -4 times -2 is +8. We add them all up, we get -48. Okay, And that's all there is for multiplying, at least for this video. Now we're going to move on to our final topic, and we're going to talk about inverse relations, inverse functions. I'm only going to show you one thing about inverse relation, because you are going to be talking about mostly inverse functions. You only have like 1 or 2 questions about inverse relations. So if I gave you this relationship, and I said when x is 2, y is 4. When x is -3, y is 6. When x is -1, y is 5. And when x is 7, y happens to be 12. An inverse relation, so this is my relationship f. Let's call it relationship f. I want to know what f -1 is, or the inverse of our relationship f. All that means, all an inverse means, is that we are taking x's and y's and switching them. And this is going to be true whenever we switch over to inverse functions. We're going to be switching the x and y values and getting a new equation. Well, if the first number in these relationships are x and the second one is y, what is the inverse relationship? Well, I just switched the numbers, 4 and 2. Here, 6 and -3. Here, 5 and -1. Here, 12 and 7. So f is this relationship. The inverse of f, as we denote f to the exponent -1, is this relationship where they're switched. And that's all I'm going to talk about inverse relations. I'm going to switch over and let's talk about inverse functions. Okay, so inverse function. All right. If I wanted to find, let's say, yet again, just like before, I have some function or relationship. F of x is 5x minus 6. So this is my function. I want to know what is the inverse of this function. Now in your assignment, they're going to ask you something like, they're going to give you f and g. And they're going to say, is f of x an inverse of g of x, or and vice versa, is g of x an inverse of f of x? And it's a yes or no question. Here on the video, I'm going to show you how to calculate it, so then you can check and see, is it yes, is it no? And I'm going to show you the steps going along the side. First thing you need to make sure that you understand is that f of x and y are interchangeable. Okay? So f of x and y, these are interchangeable things. So the first thing I want you to do when you start these is go ahead and say, instead of f of x, I'm going to call it y. So replace f of x with the letter y. Okay, so replace f of x with y. The next step, which is the step that's the most important, is this. What have I done here? Well, y was over here, now it's right there. X was over here, and now it's on the opposite side. What I have done is just like what we did with the inverse relation, I have switched x and y. Now notice the 5 did not move. So I'm not moving numbers. I'm only moving these two letters. I'm switching their places. Once you have done this step, you then solve. What are we going to solve for? We're going to solve for the letter y. We're going to work through this problem and try to get y by itself. And when we do this, we're going to find the inverse relationship or the inverse function. So, first step in doing this, I need to get 6 over there. So x plus 6 is equal to 5y. I added 6. Now I'm going to divide by 5. I'm going to divide each thing by 5. So I've got 1/5 x plus 6/5 equals y, so y is equal to 1/5 x plus 6/5. All I did was rewrite it. And now the final step that I'm going to do, you're not required to do this, but you need to know what we're doing, is that now that I've solved for y, we no longer have f of x. Now that I've switched them and then solved, we have that f of -1, or that inverse function, 1/5 x plus 6/5. I'm just going to put y changed f -1. This is our answer. What we're going to do is compare, at least in your case, is this the answer that they would have given you as the second function? I don't have that here because I'm showing you how to solve all the steps. Okay, so going back to this question, is f of x an inverse of g of x? You would now, once you've done all of this, you would now be able to answer yes or no on your IXL questions. Okay, now I know it's a bit confusing, but you've got to practice this technique. It does not come that easily if you don't practice it a little bit. Okay, so I'm going to do one more linear, and that's going to be enough for those of you that are my algebra, CR, or liberal arts students. At that point, once I finish this question, you're going to be done with the video. You can go ahead and stop. Algebra 2, once I get done with this question, I'm going to switch over and show you quadratic and cubic inverses, so that way you can answer your questions. All right, so f of x, let's say it is 2x minus 4. And I want to know what is the inverse function. Okay, first thing, f of x is y. Second thing we do, we're going to switch x and y and solve. So now solve this. So add 4. I divide by 2. I do my little rewrite. And then I change y back to f -1. Okay, simple steps. Make sure you follow them. F of x becomes y, switch x and y, and then follow your normal rules of algebra, add 4, divide by 2. You don't necessarily have to do the rewrite step. I do that because most of you like your y variable to be on the left, x variable on the right. Let's put it in slope-intercept form. So I do this little extra step that's not required. Technically, this step is not required either, because all you need to know is this piece right here and compare it to your original. Sorry about that pop-up. It keeps having some issues with some of my software. Okay, algebra students, algebra 1 CR and liberal, you are done. You can stop the video now and go ahead and start working on your homework. Algebra 2, you need to hang around because we need 3 more problems to talk about for you. So here's what I got. F of x is equal to x plus 7 squared, and g of x is equal to the square root of x minus 9. Is g of x an inverse of f of x? And it's a yes or a no. But now right off the bat, when I look at this, I can already tell you no. And I tell you this because of this piece right here with this piece right here. They're not really related. But let's go through the steps for how we do this. So I'm going to take f and find f negative 1. And if f negative 1 and g, if they match, then they're inverses, and it would be a yes. But if they don't match, it's a no. So, right off the bat, let's go through the solution process. F of x is equal to x plus 7 squared. First thing we do, we say f of x is the same as the letter y. And then, what we do is switch them. And now we go through the process of solving for the letter y. Well, I can't really do anything with this because of this squared in the way, so I'm going to get rid of it. So y plus 7 is equal to the square root of x. And then I solve for y by subtracting 7. Y is equal to the square root of x minus 7. And so this is supposed to be g of x. That's what g of x should be. Now if we scroll up and look, g of x says that it's the square root of x minus 9 all under the square root. Therefore, this and this up here do not match. Therefore, this is a no. They are not inverses of each other. What about, same question, is it an inverse or not? F of x is equal to negative 3, 5x minus 8, quantity squared, plus 3, and g of x is equal to negative 1/5 square root, negative 1/3 x, plus 1, plus 8/5. So now, this one you can't really tell right off the bat if it is an inverse or not. There's no distinct, like the last one, it was a 7 and the other one had a 9. That was kind of distinct. There was no 9 or no way to really conceivably get a 9. Here, 1/5, 1/3, 1, 8 over 5, all of those numbers, 1, 5, and 8, and 3, are all up here. So it's highly possible this could be an inverse. But in order to tell, we've got to go through the solution process. So here's our original function. We replace with y. And we go through the solution process. Okay, now I'm going to subtract the 3 over here. So x minus 3 equals negative 3, 5y minus 8 squared. I'm going to go ahead and divide because I can't really take the square root until this is by itself. I mean, I could, but I really don't want to with this negative 3. So I've got negative 1/3 x plus 1 equals 5y minus 8 squared. Now see, now this is starting to look familiar. Look at this negative 1/3 x plus 1 right here, negative 1/3 x plus 1. That's starting to look pretty familiar, especially since I know the next step is to take the square root of this side, which would put all of this under the square root. Now, does that mean that I can automatically assume it's an inverse? The answer is no, I cannot, because these numbers might not work out to match the numbers at the top. You never know until you finish the problem. So I've got the square root of negative 1/3 x plus 1 equals 5y minus 8. Well, I'm going to add 8. Negative 1/3 x plus 1 plus 8 equals 5. Why? And divide by 5, which means divide this thing by 5, divide this by 5. I want to make sure this is very clear. You do not divide what's in here by this 5. It's written out front 1/5. Alright, so this whole thing is supposed to be g of x. Is it? Well, if we scroll up, and I might be able to scroll up just enough where we can see them both. There we go. Are they the same? And the answer here is no, they are not. Now, could they be? Right off the bat, looking at them, could they be? Well, let's think. At this step right here, what technically is supposed to be here at this step? A positive or a negative. Since I took the square root of both sides, technically this square root is a positive and a negative, which means that here it's a positive, negative, here it can be a positive or negative, and here it could be a positive or a negative. Well, based on that rule, right here, since this says negative, I'm allowed to say that this could be the negative 1/5 square root negative 1/3 x plus 1 plus 8/5. Notice that plus minus does not apply to this 8/5 over here. It only applies to the radical. So yes, this is the inverse. You just have to make sure you remember this rule. So don't go slacking on your rules of algebra. You got to remember everything. All right, last one, and I want you to try to work this one out. Tell me a yes or a no. 3x plus 1 cubed minus 1. G of x is going to be the cube root of x minus 3 plus 1/3. Okay, so pause the video, work this one out. Yes or no? Okay, hopefully you worked this one out. Answer here, for those you just want to know, this one's a no. All right, solution process. As always, we switch it with a y. Switch them. I added the 1, move it over. I'm going to divide by 3. So I've got 1/3 x plus 1/3 is equal to y plus 1 cubed. And I'm going to take the cube root. Now remember, cube roots do not get a plus minus. So if it came down to the wire and it was, oh, is it positive or negative, cube roots don't get that. Only square roots, even roots, get pluses and minuses. Okay? Well, right off the bat here, I'm going to subtract 1. But really, I think we already know the answer. Because if we look back at the original, there's no 1/3 under the radical. And here, we have 1/3 under the radical. And that is why we got an answer of no. Okay, with that, ladies and gentlemen, that is all there is for this video. We are done. This should be the last video you have to watch for this year. All right, talk to you later.